Hi guys, this week we are talking about forces and motion. Two of our vocabulary words this week are acceleration and deceleration. And you have to be able to calculate acceleration and deceleration for your quiz tomorrow. So if you're still struggling with how to actually do these calculations, I'm going to walk through a few of them with you. Firstly, we need to remember that when we're calculating acceleration or deceleration, we have to know final speed, and this has to be in meters per second. Also, we need to know initial speed. Again, meters per second. And finally, we need to know time. And this is going to be in seconds. Once we know these parts, final speed, initial speed, and time, we can write our equation for acceleration or deceleration. So, acceleration equals, we're going to keep the same color coding to keep it simple. Final speed minus initial speed, all divided by time. Let's look though really fast before we move on and remind ourselves what units these have to be in. So our final speed has to be in meters per second. Initial speed, meters per second. In time, we're going to put in seconds. Now that you know the equation though, we might be asking this question, but what is that final unit of acceleration? Well, I'm glad you asked. To derive or find the units of acceleration or deceleration, we have to look at those units that we attach to final speed, initial speed, and time. So if we're calculating acceleration, and we know we have on the top meters per second minus meters per second all over seconds. Let's simplify this. Meters per second minus meters per second is going to give us meters per second on top. Then this is all over seconds. So this again can be simplified from meters per second to meters per second squared. Let's practice using our equation acceleration equals final speed minus initial speed divided by time with a few examples. For our first example, we know that final speed equals 10 meters per second, initial speed equals 2 meters per second, and time equals 4 seconds. So let's set up this problem. We know that acceleration is going to equal 10 meters per second minus 2 meters per second, all divided by 4 seconds. So I want you to pause the video and take a moment and try to solve this problem on your own. All right, so you're back. How did you do? Were you able to say that 10 minus 2 meters per second equals 8 meters per second, all divided by 4 seconds? Were you able to simplify that more than to say 8 divided by 4 is 2 meters per second squared? If not, that's okay. That's why we're practicing. So we're going to try another example now. For our next example, our final speed is going to be 24 meters per second. Our initial speed is 12 meters per second, and our time to go from our initial speed to final speed is 3 seconds. So let's set up our equation again. We know acceleration equals 24 meters per second minus 12 meters per second, all divided by 3 seconds. So pause the video here and give yourself a minute to try to solve this acceleration problem on your own. All right, so you're back. How'd you do this time? Is practice making it a little bit easier? Were you able to say that 24 meters per second minus 12 meters per second is 12 meters per second, all divided by 3 seconds, and then simplify that? 12 divided by 3 is 4, and 4 meters per second over seconds is meters per second squared. Were you able to get that? We're going to do another example, but this time we're going to talk about deceleration. If you've noticed, so far on our examples, our accelerations are positive, meaning that they're speeding up. So let's talk about deceleration and what happens when we have a negative acceleration. All right, welcome back to our next example. This time we're going to talk about deceleration. If you remember from your reading, deceleration is just negative acceleration. So for this example, we have a final speed of 4 meters per second and an initial speed of 8 meters per second. So you can see that our initial speed was faster and we slowed down from 8 meters per second to 4 meters per second. This slowdown occurred over a 2-second period. So let's solve for our deceleration or negative acceleration. So we know acceleration equals final 4 meters per second minus initial, which is 8 meters per second. And that this occurred over a 2-second time period. So we divide by 2 seconds. We're going to solve this first one together. And then I'm going to do an example where you can do it on your own. So 4 meters per second minus 8 meters per second is going to give us negative 4 meters per second. We know then this is divided by 2 seconds. So what is negative 4 divided by 2? Well, we know 4 divided by 2 is 2, but that negative is going to stay because it's a negative divided by a positive. So we have negative 2 meters per second squared. This negative number is going to be super important when we're talking about whether or not something is accelerating or speeding up or decelerating and slowing down. For our next example, we can see that our final speed is 4 meters per second. Our initial speed is 20 meters per second, and our time of our slowdown from 20 to 4 is 4 seconds. So let's set up this problem together. We know that A, acceleration, equals final speed, 4 meters per second, minus initial speed, which is 20 meters per second, all divided by our time, which in this example we said is 4 seconds. So I want you to pause the video and take a second and solve this problem yourself. All right, welcome back. How did it go? Were you able to say that 4 meters per second minus 20 meters per second equals negative 16 meters per second, all divided by 4 seconds? Were you then able to simplify that even more, knowing that negative 16 divided by 4 is negative 4 meters per second squared? If so, great job. If not, great job to you too for trying, because remember, we're learning and growing together, so practice makes everything so much easier. So keep practicing, and if you have to, write a few examples for yourself just to try your own math skills at calculating acceleration and deceleration.